This video is on the objective find the magnitude and direction of a vector. And this is the second video on this objective, so I'm hoping that you've seen the first one. So I'm just going to get right into the question. Again, if you want to see more about this, click on more instruction. Look at their notes, their videos, their examples. Hopefully those help you. Alright, so we have the vector, going from point P to point Q, has initial point P at the point 3, -6, and terminal point Q at the point, 0, -3. We're asked to, find the magnitude and direction of vector PQ. Alright, so what I'm going to do is actually write the vector PQ as a position vector. I'll first draw this, and then we'll draw it as a position vector starting from the origin. So let me go to some paper here, and I'll draw this out. Okay, so we have our coordinate plane. Now the point P, they said, was at 3, -6. So there's 3, -6. So here's point P. Alright, and then point Q, they said, was at 0, -3. Right, so 0 and then -3. And here on the y-axis is point Q. And the vector, the vector is the vector from P to Q. Remember, the arrow tells you which direction the vector is going in. So starting from P, the motion to point Q here. Alright, now what I'm going to do is I'm going to write this in component form, with the wedges. And remember, the components tell you how describe the motion. Alright, the first component is describing the left-right motion. Then the second component is describing the up-down motion. And remember, an easy way to find these is just do terminal minus initial. The ending coordinate minus the starting coordinate. So the ending x coordinate is 0. Minus the starting x coordinate is 3. Right? So 0 minus 3, it's -3. That just means that I moved left 3 units, and you can see that motion here. If I want to get from P to Q, right, I'd have to move left 3 units and then up 3, so I'm hoping for +3 here. Again, just take terminal minus initial. The final y coordinate at Q is -3 minus the initial y coordinate was -6 at point P. And -3 minus -6 is -3 plus 6, which is +3, right? So here's the vector PQ. Right. Now what I'm going to do is I'm going to draw that same vector, but as a position vector, right, starting from the origin. I'll do this in a little different color. So I'm basically moving P to the origin and going left 3, up 3. Right, just drawing the same arrow again. So left 3 units. I'm trying to keep these evenly spaced. And then up 3. And so we're landing, right, we're landing at this point here. And this is like where the point Q gets moved to. And these should be the same vector. Now I know it's a hand drawing, so they might not look exactly the same, but they should be the same length, pointing in the same direction. All right. Here is vector PQ, right, just drawn in a different place. Because remember, all these vectors you can draw starting anywhere, as long as they describe the same motion. Okay. Alright, so the first thing we're asked to find now is the magnitude, right? That's the length. So if you recall from the first video, remember, to find the length is just basically using the Pythagorean theorem. Alright, look at this vector here. PQ drawn starting at the origin. If I go, I went left 3 and then up 3. And do you see the right triangle formed here, where the vector is the hypotenuse, and this leg has a length of 3 units, this leg has a length of 3 units, so this leg has a length of, it would be 3 times the square root of 2, but remember the magnitude of PQ, which is this, like absolute value symbol, magnitude, length, is just the square root of the sum of the squares of the components. So negative 3 squared plus 3 squared. All right, so this would be the square root of 9 plus 9, which is the square root of 18, which is, yes, 3 times the square root of 2, right? This is the square root of 9 times the square root of 2, 3 root 2. All right, so the length of the vector, and this is, one thing we were asked to find. There's the magnitude, how long the vector is. The other thing we're asked to find is its direction. All right, now this is the direction off the horizontal from the positive x-axis. Right, so I'll highlight the positive x-axis, and the direction angle is the angle that's counterclockwise until you hit the vector. All right, so this is theta. All right, this is called theta. All right, well, that's clearly bigger than 90 degrees. Now, if you want to use the relationships that were brought up, last time, remember, if I call the first component A and the second component B, remember the tangent of this angle, theta I just drew, will just be the y component, or the second component divided by the first, b divided by a, or 3 divided by negative 3, which is negative 1. Right, so the tangent of theta is negative 1. Now they were telling you in the last video, right? They're telling you in the instruction to then take the inverse tangent, but that's not going to be giving us the correct angle. What it does is it gives us the size. It'll help us determine the size of the reference angle. Right, here's my right triangle. Remember, the reference angle is formed by the vector and the horizontal axis. I'll call it R for reference. What the inverse tangent will do is kind of give us an idea as to what the size of the reference angle is. Right? If I do the inverse tangent of negative 1. Now, negative 1 is an easy number. What angles had a tangent of negative 1? Well, those were 45 degrees, or I'm not 45. Sorry, we're in quadrant 2 here. So 135 degrees. But if you punch this in your calculator, go ahead, pull up a calculator, make sure you're in degree mode. If you punch in the inverse tangent of negative 1, remember it's going to spit back negative 45 degrees. Because if you recall from the chapter on inverses, inverse trig functions, when you take the inverse tangent of some number, it'll give you an angle from negative 90 degrees to 90 degrees. So just in the right half of the plane. So if our vector ends up pointing in the left half of the plane, we have to do something else. But this will tell me something about the reference angle, though. All right, this tells me that the reference angle is 45 degrees. Kind of gives you the size of the reference angle. Right? So this reference angle is 45 degrees here. All right. So in my picture, that's 45. So the angle theta is just 180. Negative 45 would be in quadrant 4. I would just add 180. All right, just add 180 to this plus 180 degrees. Now you don't always have to do this, but just draw a picture and figure out how to get to that vector. Or I know the reference angle is 45, so this must be 135 degrees. Right? The angle in quadrant 2 that would have a tangent of negative 1. So however you look at it, this theta here must be 135 degrees. And that's our direction of the vector, direction angle. So it's 3 times the square root of 2 units long, and it's 135 degrees off, counterclockwise from the positive x-axis. And that's what we'll enter. looks like this option here. Wonderful. Okay. Alright, so again, hopefully watching me go over this, looking at the more instruction if you need to, reading the answer explanations when they come up, hopefully those make sense, help you out. And I'm hoping all this stuff helps you when you go about working on the material on your own. All right, thank you very much for watching.